Hi everybody, we're talking about Euler diagrams and syllogistic arguments in this screencast. So what I want you to learn from this screencast is how to determine the validity of a syllogistic argument using what's called an Euler diagram. That word is Euler. It looks like Euler, but the word is Euler. So let's compare symbolic arguments to syllogistic arguments. With symbolic arguments, you use words like and, or, if then, and if and only if. Now let's compare that to syllogistic arguments. With a syllogistic argument, we use words like all are, some are, none are, or some are not. Now we just got done with these symbolic arguments. How did we prove those were true? We used truth tables and we used recognized forms. With syllogistic arguments, we're going to prove they're true using an Euler diagram. Okay, so here's where we're using a little bit of that set theory and we're applying it to logic. So there's going to be 4 different scenarios. Every single syllogistic argument you're given can be depicted using these methods, using these ideas. So all A's are B's, meaning every element of A is in B. No A's are B's, so the elements of A are not in B. Some A's are B's and some A's are not B's. Stop for a minute, pause the video, look at those, absorb that, see if that makes sense to you. Now let's look at an example. Let's consider this syllogistic argument. The premises, which are written above that solid blue line, the premises are all professional basketball players are over 6 feet tall. Steph Curry is a professional basketball player. And the conclusion is, therefore, Steph Curry is over 6 feet tall. This is a syllogistic argument. Notice it's using the words like all or none. Now, the first step is to identify what we're going to identify as our sets. So we're going to call set A the set of people over 6 feet tall, and B the set of people that are basketball players. I got that from the first premise. Which of these diagrams would you use to represent this situation? Hopefully you picked the diagram that shows the set B contained in set A. Because remember, we have to assume that that premise is true, which says all basketball players are over 6 feet tall. Now, where does Steph Curry have to go? Once again, assume all the premises are true. So, since the premise is that Steph Curry is a professional basketball player, he has to go in the professional basketball player circle. Since he's inside the B circle, he's automatically inside the A circle. This argument is valid. There's no other place for us to put Steph Curry. So he is over 6 feet tall. Okay, let's look at another example. Some professional basketball players are not over 6 feet tall. Nate Robinson is a professional basketball player. Therefore, Nate Robinson is not over 6 feet tall. Okay, first we set our sets. So we're going to call set A our set of people over 6 feet tall, and set B the set of people that are basketball players. Which of these diagrams should I use? I should use the diagram with overlapping circles. Some professional basketball players are not over 6 feet tall. Here's the professional basketball players. Here's the people over 6 feet tall. Where does Nate go? Nate is a professional basketball player. He has to go in the B circle. Has to go in the B circle. You have to assume all the premises are true. But he doesn't necessarily have to go outside of the A circle. The only obligation I have is to put him in the B circle. I have no obligation to keep him outside of the 6 feet tall people. That's why this argument is not valid. it is invalid. Okay, let's look at another example. No professional basketball players are under 6 feet tall. Steph Curry is a professional basketball player. Therefore, Steph Curry is not under 6 feet tall. Premises, conclusion. Which of these diagrams should I use? Yes, the diagrams we should use is those disjoint circles because no basketball players, here's the basketball players, are under 6 feet tall. A is the set of people under 6 feet tall. Now, where does Steph have to go? Remember, we got to assume all these premises are true, which means Steph has to go in the basketball circle, which means that he is not under 6 feet tall. And that argument, that syllogistic argument, is valid. All right, have fun with these. They can get a little tricky. Email me if you have any questions.